Good morning all of you. Today we are going to discuss about digital logic circuits, which is in DLD. These digital logic circuits means it takes input as binary values and gives output as binary values only. These digital logic circuits are mainly of two types. These digital logic circuits are two types. First of all, combinational logic circuits, and second one is sequential circuits. Whereas in these combinational logic circuits, we only use input values to produce output values. Whereas in these sequential circuits, we give input variables along with the previous output value as an input for the next output value. Now we are going to discuss about the differences between combinational and sequential circuits. These are combinational and these are sequential circuits. This is the diagram for combinational logic circuits. These are the input values and these are the output values. Here there is no feedback element. Here we use only input values to produce output values. Whereas in sequential circuits, this is the sequential circuit. We use external inputs and these are external outputs, and this is the previous state and here it is next state. These are external inputs and here these are external outputs, and this is the memory. Here we use memory element to store the external next input, and here in sequential circuits we use previous state input to get the next state. This is the first point. And second point, here there is no feedback element. Here there is a feedback element. And third point, it is the time independent. So this is the operation speed is much faster than sequential circuits. Here there is a time independent because the input comes to memory and the output comes to memory, and again we give as input to the logic circuit. It is time dependent. So operation speed is much slower than combinational circuits. Now we are going to discuss again about sequential circuits. As we discussed later, sequential circuits are digital circuits which store and use the previous state information to get their next state. Here we forgot to discuss about the examples for combinational circuits and sequential circuits. Here examples for combinational circuits are adder, multiplexer, etc. Here examples for sequential circuits are flip-flops, timers, counters, etc. We know that digital logic circuits we use only binary values as inputs and outputs. The binary values we use here are 0 and 1. Now sequential circuits, we discussed about the definition of sequential circuits. These sequential circuits we use the sequential circuits we use here because here we use the sequential circuits in flip-flops which they store in binary values to get their state even when input varies. First of all, we will discuss about difference between synchronous and asynchronous sequential circuits. Synchronous sequential circuits. First of all, we will know about the diagram of synchronous sequential circuits. In synchronous sequential circuits, we use clock signal. And this is memory. And these are inputs, external inputs. And these are external outputs. Same previous state, next state, and internal input. Here external, internal output. Synchronous sequential circuits are digital circuits in which feedback to the input varies for the output. Feedback to the input for the next output generation is governed by clocked signals. Whereas in asynchronous sequential circuits, the feedback to the input element varies for the output variation not governed by clocked signals. Okay, here in synchronous sequential circuit we use clock signals, and here it is not governed by clocked signals. This is the first point you have to remember. And the second one is here we use unclocked flip-flop. Here we use a clocked flip-flop as a memory element. Here we use unclocked flip-flop as a memory element. And here in synchronous sequential circuits, it is easy to design. Here in asynchronous sequential circuits, there is a chance to enter into the wrong state because of time difference between the input variables. So here the design is difficult, and here the inputs are reliable and predictable. Here the output is not reliable and predictable and unpredictable either. And synchronous sequential circuits are more. Here it is a time taking element because here the next output generation it will take into the memory element and it gives as the input for the combination circuits. So it is time taking delay here, and it is faster than synchronous sequential circuits.